Hello. In this video, I will be explaining how to use the kinematics equation that does not contain the variable time. The equation, which can be seen at the top of a page, consists of four variables: final velocity, initial velocity, acceleration, and distance, or displacement, depending on the question. To explain to you how to use this equation, I will be solving two sample problems. Here's the first. An item is dropped from the top of a tall building. When the item hits the ground, it is moving at a rate of 32.1 meters per second downwards. How tall is the building? The first step to solving this question is to write down your given variables. We know that the initial velocity, vi, will be equal to 0 meters per second. We know this because it says that the item is dropped, implying that the initial velocity is 0. What we can also gather from this information is that the acceleration will be 9.8 meters per second in the downwards direction. This is the acceleration due to gravity. Because it does not explicitly state the acceleration of the object, we must assume that it is the acceleration due to gravity. And then finally we have the final velocity, Vf, which is equal to 32.1 meters per second downwards. Next thing we can also do is put the initial velocity in the downwards direction because it is 0. And do not make this mistake. Make sure your acceleration is in meters per second squared. Now, the next step is to write down your required variable. In this case, it is delta d, or displacement. After this, write down your original equation. Velocity final squared is equal to velocity initial squared plus 2 acceleration distance. Make sure to write down your vector arrows. Now, the next thing to do is to rearrange this equation to solve for distance. Here it is delta d equals vf squared minus vi squared over 2a. Now we can start to substitute our variables in. Delta d is equal to 32.1 squared minus 0 squared over 2 times 9.80. Delta d is equal to 1030.41 over 19.6 delta d, and then we solve. Delta d is equal to 52.57194. Now we do our significant digits. We know that this one has 3, so this number should be rounded to 3, and this does not count because it is a 0. So we can just get rid of it. So we know that this one has 3, this one also has 3, so this one has 3. And when you divide 3 significant digits by 3 significant digits, you also get 3 significant digits. So delta d is equal to 52.6 meters per second in the downward, meters in the downward direction. The building is 52.6 meters high. The next question. A car accelerates from a stoplight at a rate of 13.5 meters per second forward. When the car reaches 60 meters, how fast is it traveling? So, in this question, the first thing we do, write down our givens. The acceleration is 13.5 meters per second squared. And that is forward. The initial velocity is 0 once again. You can also put that in forward because it is 0. And the displacement of the car is 60 meters forward. Now, in this question, our required variable is the final velocity, so Vf. Then we write down our original equation, Vf squared is equal to Vi squared plus 2a delta d. Then we have to rearrange it to solve for our final velocity. This is rather easy in this case. Velocity final is equal to velocity initial squared plus 2 acceleration times this displacement all squared. Then we can sub in our variables once again. So we have Vf is equal to 0 squared plus 2 times 9.80 times 13. Oh, no. Never mind. Scratch that. It should be velocity final is equal to 0 squared plus 2 times 13.5 times 60. Make sure you don't make that mistake. Let me do all of that is squared. So Vf is equal to the square root, if you put this into your calculator, of 1620, which means that Vf is equal to 40.24922 meters per second forward. And now significant digits. This one has 3, this one has 3, this one has nothing because it is a 0. So we round that to 3. 3 significant digits. The square root of 3 significant digits is 3 significant digits. So Vf is equal to 40.2 meters per second forward. And then you write your final statement. At 60 meters, the car is traveling at a rate of 40.2 meters per second forward. That is how you use the kinematics equation that does not contain the variable time.